In this lecture, I am going to show you a couple of sample programs which will show the use of pointers. In this simple program, what I have done is I have declared three pointer variables. This is first pointer variable. Declaration goes like this: int star pt. As I have told you before, it would be considered to be declaration of pointer to int. So pt is a pointer to int variable. That means pt is capable of storing address of any value, means any variable which happens to be of int data type. Similarly, float star fp. This is again declaration of a pointer variable, but this is declaration of pointer to float. That means this variable fp, pointer variable fp, would be in a position to store only addresses of float variables. Similarly, char star cp, this is declaration of pointer to char. So cp is capable of storing address of any character type value, a variable or an array element which happens to be of char data type. So apart from this, I have declared simple variables int a with the value 100, float b with the value 90.99, and char bool with the value y. Bool is the name of the character variable. So here I am writing pt is equal to ampersand a. So as of now, you know that if we write pt is equal to ampersand a, that means the address of the variable a is getting stored into pt, because ampersand is address of operator. Fp is equal to ampersand b is going to store address of b into fp. Ampersand bool, this is the character type variable, and address of this variable bool will go into cp. Of course, cp happens to be pointer to char. So then I will go and print the addresses of these variables. Address of a is equal to %u, and I am printing pt, which contains address of a, fp, which contains address of your variable b, and cp, which contains address of our variable bool. I have used the format specifier %u because addresses are going to be printed, and always remember, memory addresses are always unsigned ints. A memory address cannot be in real number like 100 point something or 120.76. It's not possible. It should be a pure integer. Neither it can be negative. No address can be like -100 or -25 something. So as you know, %u is the format specifier for unsigned long int. Unsigned int. You can also use it for unsigned long int, but the only difference is in that case you would write %lu. So %u is for, this is the format specifier for unsigned int. So let me show you with the help of this diagram. In this diagram, I have got this RAM. I have assumed that the variable a is getting stored at the address location 101. Now listen carefully. As you know, a happens to be of int data type, and any int variable is supposed to take up 4 bytes in the memory. So when I would declare a, it will take up space anywhere in the memory, and I have just assumed that it is taking up the space at address location 101. This represents only 1 byte. So a will get stored at 101, 102, 103 and 104. So I'm not showing this value 100 spread over these 4 bytes. Of course it will be spread over these 4 bytes, but I need to show only the first byte, and whenever I will explain what is the address of a, I won't say 101, 102, 103 or 104. I won't be talking about the addresses of all these 4 bytes occupied by a. I will simply say 101. Similarly, b happens to be a float data type, and because a float data type variable takes up 4 bytes in the memory, I have shown the memory address to be 113. So of course this is not the only memory location or the byte which is being occupied by b. Of course b will take up 113, 114, 115 and 116, all these 4 bytes or these 4 memory locations, but it is sufficient to say that memory address of B is 113. And as far as bool is concerned, it happens to be of char data type, and as you know, a char data type variable takes up only 1 byte, so its address is 128. So execute the program, and here is the output. I have got the addresses of these variables printed on the screen. So address of A is this 2293424, whatever the address is. The addresses that I have shown in the diagram, like 101, 102, these are just sample numbers. These are the actual addresses where values of A, B and the variable bool are getting stored.